Welcome to the first ever Student and Young Professional Plenary. We've got 7 talented young space leaders that will share their visions for space and the role that they're going to play in those futures. This is the entering the workforce and strengthening the global community, and we hope that you're going to enjoy this plenary, and we'll show you something a little bit different and what our students have to offer. My name is Ryan Kobrick. I'm the co-moderator for this plenary. I'm a PhD candidate at the University of Colorado at Boulder, working on lunar dust abrasion issues with NASA over at NASA Glenn Research Center. And this is actually my 6th IAC, and I've been sponsored by 3 different agencies over the last 7 years. Once by ESA, 3 times by the Canadian Space Agency, and twice by NASA.
I'm Kevin Stubbe. I'm with the Workforce Development and Young Professionals Committee, which has been assembled at the IAF for the last 3 years now to develop the Young Professionals program that's held at the IAC every year. I'm also on the Planetary Society Advisory Board, and this, like Ryan, is my 6th IAC. So at the end of our plenary, we do have time for questions. We have a few volunteers in the audience with paper that you can write a question on. They'll be collecting those questions and bringing them back up to us near the end of the plenary so we can keep things moving smoothly throughout the process. So to actually talk about this plenary, in the spring, in April, we had a call for people to submit a 12-second long video online. This video was their elevator pitch of how they are impacting the space industry. And you can't say very much in 12 seconds, but we had about 50 applicants submit a video. After our first round of judging, we then had about 20 of those applicants do a 3-minute video on YouTube, and that 3 minutes was to be a snapshot of what they want to talk about here today and to expand on the topics they brought up in their 12-second video. So this is some of the video clips from the winning people that are here tonight to give you an idea of why they were selected. So we have about 10 seconds from each of the participants.
I believe the future in space lies in the private spaceflight industry, and international collaboration is a very important fact for this success. Until now, space has only been available to a few of us, leaving the rest of us wondering, when do I get to go to space? How do I get to work on space? I think the answer lies in the private space industry.
My vision is to extend our concern about the Earth's environment to include space, to raise awareness of the threat that the increasingly polluted environment will play in our future endeavours. Space is no longer something that influences only through what we see on TV. It has infiltrated every aspect of our day-to-day lives.
Because many space technologies have either a direct or indirect impact on the lives of people all over the world. And in particular, satellite remote sensing, communication, and navigation can have a very direct impact in Africa.
We have got great potentiality in space exploration, but working on this field up to this day is a very grassroots level because of lack of space community, proper resources and infrastructure. So we are emphasizing more and more in public outreach and youth interactive programs. For this, we have been regularly visiting schools, colleges and public places and organizing different activities like workshops, seminars, and talk programs.
I hope to encourage the young minds today to reach for their dreams and pursue the realities of tomorrow.
One of the most important and fundamental property humans in space have is to bring a message of unitedness to the people of the world.
Sense of exploration has been the source of my passion for space research and development. I plan to play a key role in future developments by applying my expertise on the next generation of space technology and thus contributing to the global space exploration strategy.
So these are clips from the seven people we selected to be here today. And for the young professionals, our first one is Kevin Short from Canada. He's the president of the Canadian Space Society.
함용합니다.
Welcome, everybody, and thank you. And in addition to my role as the president of the Canadian Space Society, I am also pursuing research in free space optical communications at the Royal Military College of Canada.
Nikki Jordan Martinez from Columbia. She works for the X Prize Foundation as their team liaison for space prizes.
Thank you, Kevin. As he mentioned, I work for the X Prize Foundation, but I'm also involved in the Space Generation Advisory Council, where I act as the main point of contact for Colombia, as well as the regional coordinator for South America. But what is most fun, I get to also work as zero-gravity coach for parabolic flight.
And our third young professional is Shannon Ryan from Australia, who is a postdoctoral researcher at the Lunar and Planetary Institute.
Thank you. I'm involved in the design and development of debris protection systems at NASA Johnson Space Center, and I'm also working with risk assessment.
Now I'll introduce the students. Our first student is Danielle Wood from the United States. She's at MIT working on her PhD in Engineering Systems Division.
Thank you very much. It's a pleasure to be here. As a PhD student at MIT, I'm studying in the Engineering Systems Division, and my research topic focuses on strategies for satellite programs in developing countries. Thank you.
Our next student is Rajendra Thapa from Nepal. He's at the St. Xavier's College in Tiburon University. He's a master's student in the Department of Physics.
Namaskar. I am the executive founder member of Nepal Astronomical Society in NASA. Thank you.
Laura Marie Drudy from Canada. She's at McGill University, and she's a medical student.
Hi, everyone. I'm from Montreal, Quebec, and I'm a second-year medical student, and my research focus is in aerospace medicine.
And our final student is Sanjoy Sam from Switzerland. He's at the University of Washington in the U.S., and he's a PhD candidate in planetary sciences and astrobiology.
Good evening. Although trained in aerospace engineering, I'm now working on my PhD in understanding planet Earth and its context in the solar system. Thank you.
So each of our panelists is going to give you, for a few minutes, their vision for the future of space exploration. It's not necessarily what they want to do, because we all want to be astronauts, or almost all of us want to be astronauts, but it's their vision for humanity in space exploration and their role in that.
So as Kevin mentioned, this is what I like to sort of present to you for what my vision is for moving forward in the global space exploration strategy. And really it stems from the idea that there's recognizing that there is a transformation that is taking place in the international space community and how the public perceives what we're doing in space, and the fact that right now there is so much data coming down and we are no longer looking at it. People's perspectives on space exploration are no longer that we are viewing it through a window. We are actually in space, the fact that we are part of outer space and part of the universe. So with that in mind, what I would like to see going forward is certainly the continuation of development of the infrastructure in low Earth orbit. So furthering our International Space Station and our presence in low Earth orbit. Next, moving to, just go back. To developing a workable global solution to maintain the near-Earth space environment, of course, as we propagate out into the unknowns. We got to make sure that we take the lessons learned from here on Earth into space and maintain that space environment. Developing a permanent human presence on the moon is certainly something that everybody here, I think, is keen on doing, and furthering that idea of moving out into the cosmos and having a permanent representation in space. And of course, what good would any of this technology be without having the space policy to back it up and to guide the scientists and engineers? So having a more concentrated effort on the global space policy.
To accomplish this, looking at it from the short term, talking about completing the space station and examining opportunities for the end of life for the International Space Station. Of course, there are a number of options that people have talked about, and I'm sure will come up over the course of the next few days, whether or not to deorbit it. I mean, I don't think anybody would really like that idea, but having that opportunity. But more importantly, perhaps turning it over to the private space industry or other scientific organizations to further it beyond the 2015 end of life for ISS operations. Encouraging more privatization globally. Certainly the U.S. has taken the lead in terms of the private sector and handing off a lot of the routine operations to the private sector, but encouraging that on a more global scale and making people realize in other countries that they have equal opportunity to do it on their own private terms. Beginning the implementation of other LEO destinations, the space station has become a tourist attraction, for lack of a better word, of course, now that you have space tourists coming on the scene. So developing other destinations that people can shoot for, to go to, and again, furthering that idea of developing the infrastructure in low Earth orbit. Finally, in the short term, implementing more robotic missions to even farther destinations. Things like that we've seen in terms of Mars Express from the European Space Agency and Hayabusa from the Japanese. Missions like that really capture the scientific imagination and then can inspire the public's imagination as we push our boundaries and really touch the bleeding edge of discovery. More from the long term, having a permanent science outpost on the moon, this is something that would be a first step, because having that scientific opportunity and driving the science and discovery on the moon is sort of paves the way for more adventurous endeavors on the surface of the moon. Robotic missions such as the ones that everybody here may be aware of or have heard of, but scientists out there are looking at opportunities to go to Europa and other moons of Jupiter and Saturn. Having these opportunities to push our robotic technology to the outer limits. Global policy is something that doesn't happen overnight. It's something that happens in small baby steps today. So carrying that forward and concentrating and keeping an eye on the horizon for these global policies and most importantly, the associated strategies for human habitation of other planetary bodies and the development of other space technologies. And then, of course, greater global appreciation of the motivation for space exploration, conveying to the general public that we are developing this technology not just for ourselves, but to better everybody's lives here on Earth. And so these are some of the long-term goals that I think that we should be shooting for. So my role in performing this is developing the next generation of instrumentation to explore these future destinations, educating the masses of the importance of space technology development, and again, hitting home that message that we are doing this for the betterment of humanity and the preservation of humanity. Providing technical insight to these policy discussions that are taking place at conferences like this and nationally around the world. And finally, developing my personal leadership and implementing these space exploration strategies.
Hello. I want to start by saying that it's a pleasure and an honor to be here participating in this plenary and to be able to share our visions and goals with such an outstanding group of students and young professionals and an audience like you guys. As far as a personal vision for space, I believe there's two things that we need to be focusing on. One is international collaboration, and the second one is the continued success of the private space industry. I think international collaboration, it's a key for the future space missions, and the way that the private space sector is looking for innovation is what is going to define the future of space. So some short-term points to sort of follow this vision. are the following. I think that we need to keep supporting the private industry for easier and cheaper access to space. So far, we've seen very good results. For example, thanks to the Ansari Express, we now have suborbital flights. Soon enough, we will have a faster and cheaper access to the International Space Station, thanks to the COTS program. We have the opportunity to use new capabilities for lunar exploration, thanks to the Northrop Grumman Lunar Lander Challenge and our upcoming Google Lunar X-Prize. But I also think it's very important to engage the new generation in the workforce. And I believe this was a point that was touched in our last plenary. I think we really need to find a way to get the older generations and the new generations to work together so we can transfer knowledge and we're no longer reinventing the wheel. And while we're doing this, I think it's very important that we still go back to universities and colleges and schools to go and recruit our future engineers and our future scientists. We're all together going to reinvent the workspace, and we're going to take advantage of our current and new open source technologies. These technologies are going to allow us to exchange information and to promote all sorts of different space programs that are going on in our different nations. Some of our technologies that are already being used, and I think you guys might be familiar with them. We're talking about WebEx services or upstream services. We're talking about Facebook. We're talking about Twitter, etc. As far as the long-term goals, I believe that international effort for easier and cheaper access to space, just how Kevin had mentioned previously, it's very important. The United States definitely set up a very good model, and they have had a great success, so it's time for other nations to implement this model. I think it's also very important that we get to a point in the future where we're going to create a global space agency that can coordinate all sorts of space initiatives. Now, I want to point out that when we hear the word agency, we usually think about just government support. And I think that in order for an organization like this to succeed in the future, you're going to have various players, such as the government and the private sector. Now, tied to this, it's very important for us to create a global strategy with our international partners. So far, right now, we only have the International Space Station, and there's only a few players that are able to get involved in this project. So we need to start incorporating different nations. And if we're all thinking about a lunar outpost or a mission to Mars, what we need to do is bring together different technologies and different expertise from different countries, because this is no longer about a race to space. On a personal note, like I mentioned in the video, I really believe that up till now, space has only been available to a few of us. And the rest of us have been left wondering, when do I get to space? How do I get involved? I truly believe that the private sector is opening doors and will make this dream come true. It will make space available for all of us. Thanks to this, I hope to one day become Colombia's first astronaut, as well as become a great leader in this industry. International collaboration, the degree of international collaboration is very important, and that's why I think countries like Colombia really need to get involved. So I'm on my way of becoming one of Colombia's space ambassadors.
Okay, the other panelists will already have or will touch on utilization of LEO, continued human presence on the Moon and Mars, the role of the space industry in aiding developing nations and generating and strengthening political ties. My interest is in performing these type of activities in a sustainable manner, particularly regarding space debris and the pollution of the orbital environment. So 50 years of space exploration has left us with a significantly polluted environment. We're topping out at just under 6,000 tonne at the moment, and this is something that is going to need to be addressed to ensure that the following generations can enjoy the same privileges, safe access and utilisation of space that we can right now. So my vision is to look towards these sort of activities, but make sure we do so in a sustainable manner. Now, How are we going to achieve that? Well, in the short term, the issue is really mitigation of new debris generation. And I'm happy to say that in recent years there have already been some substantial advances. There was the Interagency Debris Coordination Committee, which is a collection of national and regional space agencies. The United Nations General Assembly adopted space debris mitigation guidelines last year. And these are substantial and important steps forward. At the moment, these guidelines are non-binding, so it depends on national agencies or individual spacecraft operators' goodwill. And the mitigation guidelines at the moment address the creation of protected regions, such as LEO under an altitude of 2,000 kilometres, or selected areas of the geostationary ring. In the long term, we're already faced with the unfortunate situation that the density of the debris population in some altitudes has already exceeded a critical limit. And this is called the Kessler effect, and what it means is even if we stop generating new debris, the existing population, from collisions between existing bodies, the number of debris fragments will continue to increase. This will overcompensate for the re-entry of existing fragments. So, regardless of how good our mitigation procedures are, the only way to stop the growth of the debris environment is to implement some types of active removal. There are a lot of proposals, a lot of ideas. Recent reviews, very recent this year, have shown that none of the current proposals are technically feasible and economically viable. Now, for my role, this is a big issue. Cleanup task requires a very concerted international effort. There are complex political and economical issues. Who's responsible for the debris that's already there? Who's going to pay for removing it? And these are also not small technical issues. The question arises is, can the space community learn from environmental lessons on Earth? So, recent years there's a growing interest in global warming and the control of carbon dioxide generation. And there's a real effort to try and stop things before it becomes too late, before there's irreversible damage. The longer we wait to clean up our space debris environment, the higher the cost-to-benefit ratio. The trickier these missions get, the more expensive they are, and the less the benefit. So the sooner we can address an issue like this, the better it's going to be. So my personal goal is that I'd like to participate in some sort of international effort to ensure that following generations can enjoy the safe access to and utilization of space.
Thank you. So we've heard from the young professionals, and I am now the first of the students to share my vision. And my personal vision for the future of space is that space-based services would benefit every country that needs them. In particular, satellite remote sensing, communication, and navigation. I would also hope that these services would facilitate sustainable development while inspiring young and old about the wonders of space. So looking in the short term, we can see that there are many efforts in this direction, and as a space community, I hope that we would continue to support such efforts. For example, there are many satellite-related projects for development. Some are capacity-building projects, such as the United Nations Program on Space Applications through their Office of Outer Space Affairs. They offer many workshops and capacity-building programs. Others are international mechanisms like the International Charter on Space and Major Disasters. This treaty allows any country in the world to request international help with using satellite data to respond to disasters. Meanwhile, many national space agencies are working to apply satellite data and services both locally and in partnership with other countries. One example is the project shown here, the Famine Early Warning System, which is known as FuseNet. It's a project run primarily from the United States, but in partnership with professionals throughout Africa that uses satellite data to help monitor the health of crops, to have better understanding of whether there will be a famine. And collaborative projects such as these are wonderful, but they should also be opportunities for mutual learning. The partners that bring the satellite expertise can learn from the local partners about the local context and needs, and at the same time, local partners can increase their knowledge of satellite technology. In the long term, in order to move forward in this area, we want to see more countries increase their satellite expertise locally. We want to move away from some countries having the knowledge and the expertise and others being only users, to everyone having a solid base of knowledge. It may not mean that every country owns their own satellites, but at least those that don't would also be very smart consumers because they have a core of people that understand satellite technology. Meanwhile, new countries, such as South Africa, are developing sustained satellite programs, and we're celebrating this year the launch of South Africa's second satellite, Sibandula-Sat. In the meantime, as the space community develops new technical capabilities, we will increase the number and kinds of satellite applications that are available, and these will be used in areas such as the environment, energy, aviation, and communication, just to name a few. And as we've heard, we'll need international cooperation in order to manage a possible increase in satellite activity. So for my own personal role and this vision, I'm starting by merging my knowledge of aerospace engineering and international development. As a student, I've studied engineering through the bachelor's and master's level. I've also studied policy, and now in my PhD, I'm bringing all those together in a combined way. I'm also researching the challenges of international collaborations on satellite projects. We've all talked about the need for collaboration, but it's not easy to do in a successful way, and so I hope that my research contributes to improving the way that we collaborate to bring both successful projects and mutual learning in each of our collaborations. In the long term, I want to partner with international governments to plan space strategies in developing and developed countries to increase the benefit we all receive from satellite technology. Thank you.
It is really great to be here, and I personally thank IAC grant to make my attending here possible. Okay, as a personal vision for space, I have a vision of revealing more on space exploration through Vedic cosmology. Vedic cosmology is a book on cosmology which was written 3,000 years ago. And in this ancient text, authors have chosen fundamental particles and law of force to make understand cosmology or to explain cosmology in a more dramatic way. It is really amazing to find a text which dated 1000 BC had not only similarity with modern cosmology, but it strongly opposes some of the hypotheses that modern scientists have come regarding origin and nature of universe. Here, I like to quote Dr. Stephen Hawking. Either we have failed to see 99% universe, or we are wrong about how the universe began. So actually, from this point, from this slide, a point that I want to make is to capture attention of international science communities. Yeah, there is Vedic cosmology, which can really help us to come up with greater new ideas in exploring universe and revealing mysteries, which can be very useful in space exploration. Okay, the only thing that we are unable to find or we are unable to understand science in this ancient text is because of layers of ignorance and misinterpretations that have accumulated over millennia. So researchers who are doing research in Vedic have to come with scientific interpretation so that international science communities can be assured, oh, we have really something here. We can come forth for exploring universe. And second thing is, a planetarium can be built according to the model of Vedic cosmology, where leading researchers can come and can have discussion on the scientific findings found by ancient civilization that have been encrypted in the Vaja Vedas. Okay, as a long-term vision, Vedic cosmology not only puts insight on space exploration, that means not only puts insight on knowing something about universe, but it also develops individually in individual spirituality. A point that I want to make here was not only besides giving insight on cosmology, it also helps individual to develop spiritually. So Vedic cosmology rich with spirituality and modern cosmology, if they are taken parallelly, then of course they can be a tool for guiding younger generations to explore space for sustainable peace and progress. So in 20 plus years, I have a vision. If Vedic cosmology is taken parallelly with modern cosmology, then obviously this world will be full of world citizens who are peace-loving and exploring space for the benefit of humanity. Okay, here, actually I can't figure out how I can fit into it, because here the vision is fusion of spirituality-rich Vedic with modern cosmology for better humanity. And then I have little knowledge about Sanskrit, and I have no actual research on modern cosmology, neither on Vedic cosmology. Though so, my contribution may be humble, but at least I can spread the contribution of eminent Western thinkers, scientists, and Eastern philosophers who have tried to reveal more things about universe through Vedic cosmology. Thank you.
So I'm going to be speaking a little bit about space medicine. Space medicine is truly a unique field, applying a broad understanding of medicine to the extreme environment of space. And the space environment has a vast array of effects on almost every component of normal human physiology, posing a problem to those traveling to the International Space Station and to future astronauts venturing back to the moon. And here are just some of these effects. And my research focuses on spatial disorientation at McGill, lunar dust toxicity at the University of Toronto, and fatigue risk management at NASA Dryden Flight Research Station. And all of these effects pose obstacles to those traveling to space. And to this day, there's very minimal solutions to mitigate all of these medical issues. So in the short term, I believe short-term solutions are itself an obstacle. I believe ongoing research in space life sciences is essential in order to develop a better understanding of how our body functions in space, and therefore to develop solutions to mitigate these effects. But in order for this to take place, all of these projects and endeavors need to be financially supported. And here's a photograph of a Canadian astronaut, Dr. Robert Thurs, currently on the International Space Station, and he's performing a space life science project among his many responsibilities. So in the future, I hope to see a more extensive mitigation guideline established with ongoing research in this area. And at the moment, there are only 2 civilian aerospace medicine residencies in North America. The first at the University of Texas Medical Branch in Galveston, and the second at Wright State University in Ohio. And I hope to see a growth and a development in civilian aerospace medicine programs as the endeavors to space exploration continues. So now, my role within this vision, I hope to become a leader in the aerospace medical community as a flight surgeon. After medical school, I hope to attend one of 2 civilian aerospace medicine residencies, either UTMB or Wright State, and then practice as a flight surgeon and conduct space life sciences research. And here's a photograph of myself at the age of 9 years old at the Montreal Space Center. And it was at this time, in 1998, that I saw on the big screen Dr. Dave Williams, who was a Canadian astronaut, on his very first mission to space. And I knew then that I wanted to become an astronaut. And to this day, I hope to be granted the opportunity to represent Canada as an astronaut, raising conventional thinking and imagination to a whole new level. Space truly inspired me as a child. It harbored a sense of awe, adventure, and a belief that anything is possible. And little did I know back then where I would be today. So thank you all so much for your attention, and I hope you have a wonderful conference.
Good evening. I would like to first start by apologizing for having forgotten to make my bed in the video. It is a great honor, and I would like to echo the statements of my friends and colleagues here, to be standing while sitting in front of you. It is humbling and it's fantastic. And I'm amazed by the broadness of you all here. You all come from across the world, with a broad range in education, with a broad range in cultures and beliefs. Yet you all work with the common vision to use space as an asset to make the lives of people on Earth better. You also explore space to stretch human knowledge and humanity itself beyond planet Earth. And that is very inspiring for me, and I thank you for that. However, and this perhaps applies to you as well, whenever you read the newspaper, sometimes it is difficult to find pride in our civilization. Aspects like cultural differences and religious differences, which are characteristics that should enrich our civilization, are in fact dividing us. Is there something we can do in space that can address these things? And I think yes. We in the space industry have an opportunity, or rather a responsibility, to pass on that message of unity that drives us and pass that along boldly to the people of this planet. So today I would like to invite all of you astronauts, workers in the space exploration agencies and space exploration companies, to come together and make such a statement of unity, because in space, you're all responsible for acting as ambassadors of planet Earth first. As a first step, and it's only a first step, I envision a symbol of this unity, a symbol that anybody, anywhere, can relate to, regardless of nationalities, religious beliefs, or ethnical origin. Making such a statement would be extremely powerful, particularly for the younger generation. I believe that is the blue marble, which is a picture of the planet behind me. It is the first complete picture taken by a human being in 1972. That is a universal appealing symbol. I have heard some comments that, well, Sanjoy, this is only showing Africa. That's not really fair to the others. Well, yes, but Africa is the birthplace of the human species, for one. And secondly, Africa is a political delineation that is invisible from space. It is a continental landmass like the others. The way you should be looking at this picture is seeing land, water, clouds, Earth. This is what I would envision seeing in the long term. In space, on the moon, we are, again, acting as ambassadors of planet Earth, and our planet is not represented by its countries, it's represented by its people. People anywhere in the world, and I'm sure a majority of you here, will be able to relate to such a success, regardless of who does it, regardless of where you're from. But it will not take away from the leadership of whoever agency or country achieves this. You'll know who they are. And I believe this so strongly that I founded an organization. It's a non-profit called Blue Marble Space. Its sole purpose is to promote this blue marble as an international symbol of unity in space exploration. Its base is strong, and it is growing, and I invite you to learn more about it by going to the website, oneflaginspace.org. Put yourself on the world map, join the Facebook group, tell your friends, and I would like just to finish by thanking the Space Generation Advisory Council, who have given me the framework to turn this idea from exactly that, just an idea, into a concrete project. Ladies and gentlemen, we are at a point today in the evolution of our global civilization where for the first time ever we're able to make such a statement. It is not just feasible, it's doable. So let's do it. Thank you.
So before we get into the questions, we'd like to acknowledge a few groups that made this possible today. First, the International Program Committee of the IAF that asked for and allowed this plenary to happen. Second, the Workforce Development and Young Professionals Program Committee for putting the time and effort behind this and leading the organizing of this with the Space Education and Outreach Committee. Those two committees put a lot of work in the last 6 months into organizing this, doing the competition at the beginning, judging it, and running this. The IAF Youth Grant Program is a new program at the IAF which helped fund 3 or 4 of the panelists up here tonight, as well as a total of 12 young professionals and students to come to the IAF this year. And finally, the International Student Education Board, because they helped fund several of the students who are up here and have helped fund several of the students who are here at the IAF this year. Without these groups, a panel like this would not be possible, and many of the presentations you see here at the IAC by students and young professionals would not be possible. So, questions?
All right, we're going to go into the question session now. Thank you all for your questions. We have a lot up here. I encourage you to get together with the students and young professionals that are part of our panel and all the other ones that are here at the conference and ask them your questions as we go through the week. So we'll take a few of them now, of course, and we'll get going with the first one that's to everyone. As young professionals, do you feel that you receive the appropriate training in university to prepare yourselves to contribute to the workforce? Is this from classes or from extracurriculars, and what was missing?
I'm guessing we're going in the order in which we presented, so I get to go first again. I think that to a great extent, in any case, the experience that I've gained has largely been of my own deriving, in the fact that there is a large disconnect, I find, between academia, the skills that are required or taught in academia, and the skills that are required by somebody entering the workforce nowadays, and the fact that technology today is changing so rapidly that it makes it very difficult for academia to keep up, in which case they have to keep their programs very broad. On the other hand, there are tools that are being used in industry that they're looking to us as young professionals to become familiar with in a very rapid rate. And in fact, long gone are the days that companies are interested in spending 6 months, 8 months, a year training an individual coming out of university on the various tools that are being employed. So there needs to be a greater connection between the skills that are being taught at university, the tools that are being used by industry, such that when these new graduates come out of the university setting, that they're ready to enter directly into the workforce and work for the industry.
From my point of view, I was lucky enough to be able to go to the United States and pursue a career in aerospace engineering. I definitely learned a lot, and towards the end of my career, I had the opportunity to experience a couple of internships. This is what taught me the most on how to behave during the work that was going to come ahead in my life. But I definitely think that universities need to give students opportunities earlier to either go and participate on activities like Follow an Engineer Week, or if you're in business development, go and experience what they do, or if you just want to focus on science, then maybe follow a scientist. But definitely everything that I needed to go in the work field was not provided by the university. It kind of came as the years of experience have developed.
From my perspective, I think the role of university is to, particularly for science and engineering students, is to provide a broad basis, primarily theoretical, that then you can use when you go on to your professional career and specialize in a specific area, learn the practical skills that go along with that. I agree with Nicole that there is definitely room for better integration. I got my PhD in Germany, and Germany has a fantastic tradition of especially science and engineering students doing a lot of internships in professional companies and research institutions, so that by the end of their university degree they have quite a substantial amount of experience and information about the workplace, and in my opinion, they're able to integrate more rapidly into a professional situation. So a closer bond between university and industry is a beneficial thing for everybody.
My passion for medicine actually began at the age of 16 when I was working in a cancer research lab. And I think we have all said the same thing. And I think that key word is mentorship. And I wouldn't be where I am today without the guidance of my mentors. So I think developing mentorship programs in universities for a variety of students is essential and of utmost importance.
Okay, so the next question is for all of you. And the question is, can you remember that moment that you knew space was your calling, no matter what the outcome from that moment was? For any of you.
I do remember clearly the moment that I decided to make space my career. I was an intern in 1999 at the Kennedy Space Center, and I had the privilege of growing up in Florida, so I was always nearby. But I was able to be at Kennedy on the night that Eileen Collins launched as the first female commander of a shuttle mission. They launched the Chandra X-ray telescope. It was a nighttime launch, which was an amazing privilege to see, and I was very close with several other interns for that night. And the beauty of the launch on the third try, after two other nights of scrubbed launches, gave me a lifelong inspiration. But it wasn't just the launch, it was also the whole summer of getting to know the NASA community and see that it was really a family, and there was a lot of passion in the people that worked there.
Well, I remember as well. In fact, it was January 28th, 1986. It was unfortunately the Challenger incident, and I was a wee little boy, and I was asking my parents what happened, what was the big deal. I couldn't understand anything. And they told me, well, those are people that are going into space to work. And that absolutely blew me away. Going into space, you can do that? And since then, I've been doing everything I can to gain the knowledge, experience, and vision to myself become one day an astronaut.
Now I'm going to make a comment really quick. That was actually the same moment for me. My dad was making me pretty much watch the Challenger explosion recap video, and I said, oh yeah, I'm going to become an astronaut. And he was like, what?
Hello. Yeah, it was, I would like to share my, it's like sad moments in Nepal. Still now, in Nepal, we find people dying of minor disease, that is, may not call it disease too. It's diarrhea, and the people are dying because of diarrhea. Nearly about 300 people died this year only. Therefore, I think space technology can come with telemedicine, somewhat like that. And it was actually where I was just inspired on. And then Nepal being neighboring countries of India and China, and India and China doing such great in space exploration, and Nepal not taking a single initiation in just to promoting space science. Therefore, basically we thought that we have to come now for initiation of promoting space science education and activities for younger generations, for future generations, so that they can do a lot in the field of space and technology. That's when I was just inspired in basically space. Thank you.
I remember very distinctly when I got interested in pursuing space as a career, and that happened when I read a book in grade 6 by Canadian author Terence Dickinson, and it was called Exploring the Night Sky. And what I found fascinating about this book was the fact that just the sheer size of things in space and the sheer exotic nature of space, like the fact that you have a neutron star matter, a tablespoon of neutron star matter that can weigh as much as 1,000 railway locomotives here on Earth. Just numbers like that I just found unfathomable, and it just made me want to go out and explore, and being able to see that kind of stuff and explore that kind of stuff firsthand and be the first to see those kinds of things.
I told you when my passion for space began, but my passion for medicine began when my grandmother was diagnosed with cancer. And that began my research in cancer research. And I was wondering, could I combine both these interests? And I wanted to do a Google search, and I was expecting not to find anything on the subject. But I ended up finding 2 civilian aerospace medicine residencies and a Canadian Space Agency medical elective. And that's what initiated my passion for space medicine.
Well, I probably don't have as inspirational a story as some of these guys, but coming from Australia, there's a little bit of a disconnect from the space program. I was about 12 years old. My sister had a boyfriend that was studying aerospace engineering, and he was working on a project at my parents' house. He had to build a rocket to shoot an egg 200 meters up, release a parachute, and land without breaking the egg. And I just thought that would be such a cool way to make a living.
Okay, before we take our last question, I'm just going to have a little announcement to read. Just after this, there's going to be a welcome reception that will be held in front of the Hanbit Tower at 7:30. So we hope you can join us there and ask us more questions and keep the conversation going. So our final question is open to the floor and more particular towards the young professionals. For young professionals that are not in a position of decision-making of their organization or country, what kind of methods can they engage in to sort of start international collaboration?
I'm just trying to think of the context from this question here. Are we talking about if we're talking about from the perspective of what do we as young professionals see the global, or how agencies out there and industry out there can engage the global strategy? I think that standing from the outside looking in, I think just greater sharing of data, greater communication. I mean, that's the number one reason that we're all here this week, is to really expand that network, expand that communications drive. As a young professional trying to get in or trying to stay in and move up the ranks, I think that, as Laura touched on earlier, the idea of having mentorship programs and creating these opportunities for young professionals to become actively involved, and having been raised in sort of this Generation Y, as it's being called, where we have that greater access to the international community amongst ourselves through media outlets like Facebook and Twitter, and really using those opportunities that us young professionals have been working on since playing video games earlier on, and using that technology to enhance the greater global cooperation and communication.
I'm going to second kind of like what I said in my presentation for that question, and a little bit of what Kevin just said, but really it all relies on working together with the different generations to transfer the information in order for the new generation to start making decisions. It's not like we don't want to make decisions. Believe me, if you put us in a position where we're given the opportunity to do them, I think this generation definitely it's very opinionated and likes making decisions, but we want to learn to make the right decisions. So it's a matter of mentorship. And if we do make mistakes while making this decision, it's okay. We'll learn from it. But coach us and give us the opportunity to participate in conferences like this, or give talks and go and learn from different fields. And I think that's the best lesson that you can pass along to us, so we can further down the future make the right decisions for generations to come as well.
Since I started graduate school in 2005, I've been working with a professor at my university to help establish an international collaboration with a university in South Africa. It's the University of Pretoria. So I've been able to be involved in a very direct way in forming this collaboration, and partly because I'm basically allowed to take as much initiative as I'm interested in to be involved, and because the people who are otherwise involved are quite busy, if I choose to put time and effort into the program, I can have a lot of influence on what happens. Our goal is to have student exchanges so that students from South Africa can come to MIT and vice versa. We also want to engage in joint community service projects as well as research. And so any idea I have, if I can communicate it clearly to professors on my side as well as in South Africa, can possibly be implemented. So even though I'm not the final decision maker in the situation, because I've proven myself as someone willing to work on the project, I've had opportunities to influence the outcome, especially because one of my roles is to maintain communication with the university. Often I may be the only one who knows what everyone is thinking, so I can take opportunities to make sure that everyone is fully informed and also share my own ideas. So even without being in a full decision-making role, if young professionals and students can clearly think through an idea and communicate it to their superiors, we can have influence.
So we'd like to thank and congratulate our panelists again for going through the selection process to be here and coming to Korea to share their views with you. So please congratulate them. And we have to wrap this up now for the welcome reception, but they will all be at the welcome reception. We encourage you to find them while you're there. Ask them any questions you want. We're going to take the rest of the questions that were submitted, share them with the panelists, and collect their answers for you and post them on the IAF Young Professionals website, which is part of the ifastro.org website. So thank you again for coming and enjoy the evening.